All right, we're back. We're on page 3 of notes 9 of Calc C, and I just realized that on the previous page, I actually didn't do the whole problem, which says write the series in expanded form by writing the first 4 non-zero terms and the general term. I hate doing that. I'm gonna do it for this one. I hate doing it because it's annoying. The main thing that I ever see anyone mess up is that they, for whatever reason, don't write pluses in between the terms. So like here, it's x to the 4th plus x squared over 2 times 4 squared. Don't get obsessed with, or what am I thinking here? Don't get obsessed with simplifying. It's not what it's about. It's about just writing the terms and moving on with your life, plus dot, dot, dot. And the general term, so plus x to the n, 4 to the n, plus dot, dot, dot. There you go. That's the whole thing. So you could go back and do that. I'm definitely not going to because I hate that step. So we're going to find the interval of convergence, though. I love finding that. So let's see if we can do it. So we start off, we're going to go to limit as n approaches infinity. So we're finding the open interval on which this thing definitely converges absolutely. Then the question is, like, what happens at the endpoints? If you have to guess, by the way, I'm going to guess that this thing converges between -4 and 4. Like there's something very 4 about this. This is going to like cancel. Then it'll be the absolute value of x is less than 4. That's my prediction. Let's see if it comes to pass. So n plus 1, 4 to the n plus 1 times n, 4 to the n, and then x to the n. All right, what space are we working with here? Plenty of space, maybe. So am I still gonna have an n here? I guess. I mean, I'm okay with you skipping this step, to be honest. So there'll be an n and an n plus 1, and then there'll still be an absolute value of x and a 4. And when you take the limit as n approaches infinity, you just get the absolute value of x over 4. So that's rho. That's our ratio. We use the ratio test. We know the ratio test says this thing converges anytime rho is less than 1. So converges absolutely for the absolute value of x over 4 less than 1, which means, so you want to isolate the absolute value of x minus a. So a in this case is 0. So the absolute value of x is less than 4. As soon as you get to this, you just found the radius of convergence. So this is the radius. So you're at 0, you go 4 in either direction. That's going to be the open interval on which this thing definitely converges absolutely. So converges absolutely for. So I don't know why I always draw this on a number line. I mean, it's not a bad thing to do. Just I don't know why I do it. So we don't know what's happening at the endpoints, but we know it definitely converges absolutely on the interior of this. Our question marks are here and here. What's happening there? Does it converge conditionally? Does it diverge? Does it also converge absolutely? Like, let's find out. So the way we do that, let x equal -4. And if x equals -4, our series becomes, what does it become? It becomes, oh, well, first of all, you're starting at 1, not 0. I don't think you ever really lose points for that because, like, I'd be surprised if anybody even notices. We got to plug -4 in there. So you get -4 to the n over 4 to the n is -1 to the n over n, alternating harmonic. So this converges conditionally, but converges by AST, or because it is the alternating harmonic. Either one's good. If we let x equal 4, then we just get 1 over n. Let me check that. I'm pretty confident. Yeah, you get 4 to the n over 4 to the n is 1 over n. This diverges because it's harmonic, or p equals 1, whichever. I'm gonna write harmonic. And so then we can say our conclusion. So we converge at -4, we diverge at +4. So I get, like, I have this sense, I don't think this is true. I have this sense that they converge more often on the left endpoint than the right endpoint. I don't know if that's like a thing. I think it shouldn't be. So the interval of convergence is converged at -4, not at 4. There you go. And that's the work. And it looks pretty good. Let's try the next one. N to the, is this gonna have E in it somewhere? Possibly, because like N to the N, and then there's gonna be an N plus 1 to the N, and like, we'll find out. I'm not gonna write any terms. We're just going for it. Limit as N approaches infinity. All right, so it's X plus 2 to the N plus 1 over N plus 1 to the N plus 1. Great. And then N to the N, and X plus 2 to the N. All right, so some careful consideration on this one. Let's see, this will be limit as N approaches infinity of, so what I'm gonna do is I'm gonna make this N plus 1 to the N times N plus 1. N plus 1 to the N times N plus 1. And the reason I'm doing that is that then I'm gonna have an N to the N, an N plus 1 to the N, a 1 over N plus 1, and then the absolute value of X plus 2. Okay, so we didn't take the limit yet, but like that's all happening. Okay, so if N approaches infinity, I don't know how much work I want to show. So like, let me, I'm gonna add a page to mess around with this for a second. Also, I mean, I could be totally wrong. I don't think I am, but like maybe. Okay, hold on. We're doing a lot of work, potentially. Copy and paste. I hate like pasting onto a blank page because you don't know like where are you? Okay, that's where we are. All right, so I'm gonna focus in on this. Focusing on here. That I think is e to the negative first when n goes to infinity. So I'm gonna say that n to the n over n plus 1 to the n is n over n plus 1 to the n, which is n plus 1 over n to the negative first to the n, which is 1 plus 1 over n to the negative first to the n, but I'm going to switch those to the n and then to the negative first. And then if I take the limit as n approaches infinity of 1 plus 1 over n to the n to the negative first, I'm pretty sure you're allowed to do all this. This is definitely e for like every reason. Definition of e, maybe even. So that's e to the negative first. So you get e to the negative first. So basically you get a constant here is what I'm saying. And then you have the absolute value of x plus 2 over n plus 1. That definitely goes to 0. You have a constant times 0. I think that this limit overall is 0. So I'm just going to put 0 equals 0. Equals 0. And 0 is less than 1 for all x. So if it converges for all x, then the radius is infinity, which is dumb. Like I don't think you should be writing that. And then the interval is I don't know. I'm gonna write this. I'm also not a fan of this. So just x is an element of the reals. Check out that x. What is that? That was like a normal x, like the like childish multiplication symbol. Let's take a look at this one on the calculator, and then do I have a calculator open? Okay, let's leave this on the calculator and see if the calculator can help us out, which it usually can. Okay, so new calculator page. I'm going to define a of n to be x plus 2 to the n over n to the n. Okay, and then what we want to do is we want the limit. So you can do the ratio test on the calculator. It'll for the most part have no issue with it. This feels like a place where it might have an issue, so we'll find out. And then I want to do the n plus first term divided by n. Oh, I want the absolute value in there. I'm going to highlight that and put a template around it. There, and then there. Okay, worked out. I'm hoping this limit is 0. Yes. Let's take a look at, let's just make sure, I'm going to redefine this how am I doing this? I'm gonna do like, I'm gonna make this 1. No, that's not gonna work. What do I want to do? Well, I just want to see if the limit of n over n plus 1 to the n, I think that should be e to the negative first. Oh, yeah, well, what limit? N is the variable, infinity is the thing. E to the negative 1. Okay, so the logic is sound, it works out. You know, you like go for something and then you're like, did I just tell everyone watching this the wrong thing? And it turns out I didn't, but I would have said there was a chance. All right, so you know what? This is probably pretty long, so I'm gonna stop this one here, come back in the next one, and do some more. So I will see you there for more intervals of convergence.